Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see a Leetcode question number 349. Intersection of two arrays. Given two integer arrays, nums1 and nums2, return an array of their intersection. Each element in the result must be unique and you may return the result in any order. So see this example. They have given two arrays and we have to return the intersection of these two arrays and they should be in unique order. See here, there is common element as 2 and 2 occurs 2 times, but still you have to return only one time. So seeing this approach, just see here. Yes, seeing this approach, I can tell you that whenever there is a word called unique, we use set data structure. So for the approach, for to approach this problem, I can make nums1 a set and nums2 a set. Now do a set operation for this. Do a set operation that is intersection. Like we have intersection function, and also we can use some symbols. In Python we can use and symbol, right? Like this we can approach the problem, right? This is the first approach inside that set. But still, if we don't want to use the intersection function and also the symbol, we can also use another method. Like I can iterate to every values of nums1. Say the nums1 values are 1 and 2 and say nums2 values is 2. Now just listen carefully. I will iterate from 1 by 1. So first I iterate to 1. 1 is in 2, no. Now I will iterate to 2. 2 is in 2. 2 is in another set. Yes, 2 is in this set. So my output will be 2. Now my output will be 2. So this is my approach for set data structure. Okay. Can we do without set? Can we do without set data structure? So the answer to this is yes. We can use two-pointer approach. But how the two-pointer approach works? We want an intersection. So to get the intersection from random points, I can rather prefer a sorted array. Just see here. 1, 1, 2, 2. For example, here 2, 2. Now I can keep a pointer here and I can keep another pointer here, right? So a pointer is pointing to 1 and another pointer is pointing to 2. Now listen carefully. This two-pointer technique is called two input or parallel pointers, right? This is called parallel pointer technique or two input type technique. Okay, because we have two input array, we want to do a two-pointer technique, right? So this is one type of two-pointer technique. Now whether this 1 is equal to this 2, no, they are not equal, but is just use common sense and say whether in this sorted array after this 2 will 1 occur? No, right? But after this 1, maybe there is a possible for the occurrence of 2, right? So I just update my pointer to 1. Now whether this 1 and 2 are equal? No. Again update, because 1 is less than 2, right? Now 2 is equal to 2. Yes. Now my output will be 2. Now update this both pointers 1 by 1, right? Now 2 is equal to 2, again 2. Now update to the end. But they have asked us to find distinct. We have found a multiple answers. We also written set of, then it will be correct, but we don't want to use this set, right? So how to approach this problem? Again I write this. Now we can see the correct approach. Now I have 1 here and 1 here. So there are 2 pointers. Now whether this 1 is equal to 2? No. Whether this 1 is equal to 2? No, it is smaller. Now this 2 is equal to 2. Yes. First of all, before that, checking this condition, listen carefully, whether this 2 and its previous element, whether this 2 and its previous elements is, whether this 2 and its previous element is same, whether this 2 and previous element same. No, right? Now check for this condition. They both are same. Now the output will be 2. Now update my pointers. Now check whether this 2 and its previous element are same. Yes. Again update. See here too, whether this 2 and its previous element are same. Yes. Now update this pointer. It comes to null. Right? We are just taking. First we are taking as output. Then we will update the pointer until we get a unique element. So how to get a unique element? By checking nums. Let us take array is nums. Then nums of I is equal to nums of I minus 1. Then in this condition, I will update my I plus plus, right? If this is my condition, I will do this operation, right? This is my approach. So talking about the time complexity for both the solution. First of all, I will talk about the time complexity for the set solution. So what is the time complexity? Now I want to convert n number of element to set for nums1 and m number of elements to set 2. So n into n log n plus m into n log n, right? Now I have to check whether elements in n in nums1 is there in nums2. So plus n into log of, right? So this is the time complexity, overall time complexity. And talking about space complexity, it is O of n, it is n plus m, right? This is my time and space complexity. So talking about this approach, time complexity is first of all we are sorting. So it is n log n plus m log n, and we are searching by updating one by one. So it is m plus n, right? This is my time complexity. Now talking about space complexity, in inbuilt sort technique too, it uses the merge sort algorithm. In merge sort algorithm, it takes spaces m plus n. Okay, both the approaches 1 and 2 are same in time complexity and space complexity, but still one uses set and one and 2 don't use set, right? So this is the main difference. Let us see the code. This is my approach 1. See this approach 1. I just converted both the array into the set, then a result. Now for I in nums1, if I in nums2, if the element is in nums2, then I will append to the result. So this is the simplest approach that can be found at the initial step. Okay, fine, it is submitted successfully. See here. Now coming to the second solution, I have sorted the two arrays first, then I have taken the result variable and for storing the array elements. Now I have got the length of the nums1 nums2. Now while I is less than n1 and j is less than n2, if nums1 of I is less than nums2 of j, if the first pointer's element is less than second pointer, then I have to what? Step one step ahead. As I said you earlier, that if that here is 1, here is 2, maybe there's a possibility that in right side of that 1 there may be possibility of occurrence of 2, right? That's why I have written this condition. Or I is greater than 0 and nums1 of I is equal to nums1 of I minus 1, right? The current element, if the current element is equal to the previous element, then there may be chance of occurrence of a duplicate in a result. So we want to iterate one by one and jump the I variable from one by one, right? That's why I have given this, and this is the condition to avoid the error, right? Same for the J. Else. If there is a else, it is like there is no duplicates and the current element and the previous element are different, as well as the two elements, that is the I pointer and J pointer, the elements are same, right? In that scenario, I will append to the result and I plus equal to 1 and J plus equal to 1, and I will return the result. That's all. Let me run this. Yes, submitted successfully. So these are two approaches, and that's all about this. Thank you.